Okay, so for this question, we are gonna look at the compactness of an enclosed region. First, we want to understand what compactness means. If I happen to draw a triangle inside of a circle, the compactness of this triangle is supposed to be the fraction of the circle's area that this triangle has occupied. If it's leaving out a lot of space in that circle, when it's out here, that compactness is maybe 0 0.5 or something. What we want to know is the formula for compactness. It's the area of the region you have drawn divided by the circle's area. So pi by 4 d square. Okay. Now, at this point in time, with that triangle there, of course, the compactness would be around zero point 0.6 or something. Why that the area of the triangle will be, I think, about 1/6 of the 60% of the whole circle. Okay. Now, let's go increase the number of sides on this uh, polygon that we have there. So I have, let's say, an octagon here. Now I can see that the area of the octagon divided by the area of the octagon divided by area of the circle, that will be like a close to a 1, because I've got small spaces left out. Small spaces left out. See, out of that octagon. Hmm? What if I go increase the number of sides? Well, we go somewhere here. 17 sides now. I see that the polygon that I have here is almost a circle now. In that case, if I go figure out the compactness of this polygon, it's going to be area of it divided by the area of the circle. And you can see that the polygon has literally become a circle here. So this will come out to be about 1. Okay, let's go increase the number of sides more. Mm, okay, now you can see there's no difference between the polygon you have inside of that circle and that circle itself. The compactness has reached a value close to a 1. Although if I zoom in, you'll see there is still spaces left. If you can see, there is still space left. So what you're looking at is the area of an enclosed region divided by the area of the circle it is inside, and that is literally the compactness of that polygon. So we'll go back to maybe an 8, somewhere there. Okay, that's where we are, and we're going to try to figure out the expression for the compactness of n-sided polygon. And for that, I'm going to take this as an example, and let's see. So the first thing we notice is what they're asking for. So they say that the compactness is supposed to be 4a divided by pi d square. Well, it's not different from what we know about compactness. We know that the area divided by the area of a circle, pi by 4d square, is supposed to be the compactness. If you rearrange it, you will see that the 4 can be taken up in the numerator and it becomes a 4a by pi d square. That is the compactness of a region. Yes, so that formula is all right for us. And then they say show that if n is greater than 2 and even, the compactness is given by that formula. So we're going to have to figure out the general expression of compactness for n-sided polygons. For that, we're going to have to draw a diagram. So let's go look at the diagram where we actually have a n-sided polygon. There it is. Let's look at it. Okay. Now, what we have here is an octagon. So there are 8 sides to it. What is, let's look at this one. I want to look at this triangle. Okay. So when I look at this triangle, I know that this angle is supposed to be 1/8 of r 2 pi. Why? Because it's a regular polygon. Regular polygon. So I know that these angles 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. These 8 angles should be equal. and the total of it is a 360-degree or a 2 pi radians. So one of them is actually a 2 pi divided by 8. Okay. What if there were 9 or maybe 10 sides? So in that case, this angle would have come out to be 2 pi divided by 10. Okay. So you know, if there is a n-sided regular polygon, this angle in the triangle that you figure out, let's show you a larger shape. Let's go increase the number of sides to 10 maybe. And now let's try to show you the triangle we are talking about. So somewhere there would be the center, and somewhere there would be the triangle there. Now this angle is gonna be 2 pi divided by 10. This one is also gonna be 2 pi divided by 10. Or what I want you to notice is that the angle of this triangle is supposed to be 2 pi divided by n if there are n sides to this polygon. Okay, let's look at the other details that we know about the circle. Well, according to the question, the number of where is the d is the maximum distance, so d is the diameter. Consider a regular polygon of n side constructed that its vertices lie on the circumference of a circle of diameter x units. Okay, so the diameter of this circle is x units. Okay, so this thing is supposed to be x, and that is why we know that the radius is going to be x by 2. So this length is x by 2, and this length is also x by 2, and this angle I know is at 2 pi divided by n. Okay, what if somebody wants you to find out the area of this triangle? So you go half AB sine C. So half one side, x by 2 is the other side. Sine of the angle between the two sides, it's at 2 pi divided by n. What will be the compactness of this figure? If it's n number of sides here, it's the area of 1, 2, 3, 4, 5, 6, 7, 8 triangles. If it's an n-sided polygon, I'm going to have n triangles, n into that area, half into x by 2 into x by 2 into sine of 2 pi by n divided by the area of the circle. The area of the circle is going to be pi x square by 4. Now let's see what compactness here comes out to be. Um, let's take a screenshot of this and we will do it here. Give me a second. Mhm. So we have a polygon here, the area of which is n times 1 by 2 into x by 2 into x by 2 into sine of 2 pi by n. And the area of the circle is going to be pi x square by 4. Okay, so let's see what this compactness comes out to be. I know it's going to be x square by 8 sine of 2 pi by n divided by pi x square by 4. And you can actually see it coming about. You know that this will come out to be n divided by 2 pi sine of 2 pi by n. x square and x square will cancel out. The 8 and the 4 will cancel out. N and pi and the 2 from that 8 is going to stay. So basically, this is what you're going to get for the general formula of the compactness. Okay, so we go back. It's supposed to be the area of the region divided by the area of the circle it is enclosed in. And of course, the more number of sides you have, the closer you are to an actual circle for that polygon. And yes, the compactness in that case will come out to be a 1. The area of the polygon will be equal to the area of the circle. So the compactness is a 1 in that case. So that was the part A. Let's look at the part B. They say find the find the regular polygon with least number of sides for which the compactness is more than 0.99. So in a way, we are looking for a polygon, the compactness of which would be a 0.99, meaning in a way it becomes a circle. When do you feel like it is almost a circle? Okay, a 0.99 uh, would be the compactness in that case. So we know that the compactness is supposed to be n by 2 pi sine of 2 pi by n if n is even, and when n is odd, this here is the formula for compactness. If you're supposed to see the number of sides for which the compactness is more than 0.99, I'm going to go find out when is it really a 0.99. At what value of n is it a 0.99? So if you solve this on the calci, you'll come to a 20.2 on this one and a 25 point something on this one, 25.6 or something. So in a way, you're looking at 21 sides here and about 26 sides here if you solve this on a calci. Okay, so you can go to the solver on your calci, the equation solver on your calci. Drawing this curve is a problem because there are a lot of points where it looks like it reaches up 0.9, and it's a very weird graph. You can't look at the value of n or x that you may put up there, but this is what you get if you use the solver. Okay, so the least number of sides for this, for which the compactness is more than 0.99 is 21. So when I go increase the sides to about a 21, somewhere there, I am gonna see that this has become about a 0.99 of a circle. The compactness is about a 0.99, and only these little spaces are left out uh, from that circle in a polygon with 21 sides. Okay. Oh, I think I have said it wrong here. If it's the even number of sides you take and you want to look at the number of sides, and it will be, it's about a 25 point something, so about a 26 for this one and about a 21 for this one. If you solve 20.25 or something, it'll come out to be 25.6, it'll come out to be. So 26 would be the number of sides when it's the even number of sides, and 21 would be the sides when it's odd number of sides. The thing is, at the moment you get to a 21 on the number of sides, you have reached a compactness of 0.99. Okay. Now, how do you want to explain if this is a good measure of compactness? Well, there are many ways to answer it. The thing is, you can tell them if the number of sites increase to about 21, I am looking at a compactness of 0.99. That is me explaining the part C. Okay. If the number of sites have reached a 21 or a 26, I see that the compactness has reached a value of 0.99. So if I try to use this formula, For compactness, I'll not be able to differentiate between the compactness of the site of the polygons which have more than 21 sides, because from 21 onwards I'm gonna reach any value which is larger than 0.99 and lesser than 1, of course. So there's a very small um, range of values for compactness for any polygon which is greater than 21 number of sides. So it's not that clear difference. There's no clear difference between compactness of polygons with more than 21 sides. Okay, and that is what you want to say here. Or you can also tell that the compactness for uh, compactness when solved for about 0.99 for even number of sides is about 26, and for odd number of sides is about 21. So they're literally almost the same values for even and odd number of sides. And again, a very bad measure it'll be. That is how you want to say this. I'll say it again. For sides more than 21, the compactness is almost a 1. It'll be hard to differentiate the compactness between the polygons with more than 21 sides if it has already reached a value of 0.99. So that is how you want to defend uh, your answer here. Okay, so that was about compactness. A very nice um, shape here. A very nice, sh- look at that. So the compactness here, it would be about 80%. Mm. Here it will be about 90%. That's how it goes. That was the question. I'll see.